Alright, this is Mr. Gillum, and today we're going to be looking at writing and evaluating expressions on page 160 of your instruction book. Last year, the Speedster Bicycle Company held a bicycle design contest and awarded a cash prize. This year, the contest prize is $20 less than 3 times last year's prize. Evan and Gina won this year's contest and split the prize money evenly between them. We need to write an expression to show how much prize money Evan wins. And it says if last year's prize was $50, how much money does Evan win? Okay, so we need to be careful about this problem because when I first read this, I didn't really catch this. It looks to me like they've won a prize and they're going to get some money, but because they both won the prize, they have to split the money evenly. Okay, and that's really important because when it asks us to write an expression to show how much money that Evan wins, we're not talking about Gina's half. We're only talking about the half that Evan wins. So that's going to be super important. So one way we can think about this would be to picture it. Okay, and so they've drawn little envelopes here of cash money here, and this envelope represents last year's prize money. There's a key phrase here that said this year's money is 20 less than 3 times last year's prize. So 20 less than 3 times last year's prize. So if I take 3 of these guys right here, 1, 2, 3, 20 less than that will be how much they're winning this year. Now you can see that they've made also a little indication down here, and this has to actually do with just Evan's piece of the money because we're only really want to know what Evan is winning. And so what we can do is we can have it actually split that into 2 pieces. Half of it goes to Evan and half of it goes to Gina. And so that's one way we could illustrate it with a picture, is by representing what last year's looks like. Because this year's is 3 times as much, and then 20 less than that, we could have that same exact thing 3 times and then subtract 20 from it. And then because it's not just Evan's prize money, it's also Gina's prize money, we'd also have to split that into 2 parts. And so we can use algebra to represent the situation as well. So when we're modeling, it says the phrase less than tells you the expression representing this year's prize money will have this overall shape. So again, they're talking about the shape, and so the word less than is one of those phrases, the words less than, where sometimes if you're not careful you can make a mistake. So if I said 10 less than 20, that would really be 20 minus 10. So even though 10 is coming first in like the English version of how we say something, doesn't necessarily that means in math it's going to be in the same order. Okay, so you actually really need to be careful and think about the phrase less than to make sure you have things in the correct order. Okay, it says that Evan gets half of this year's prize. So remember, we're not just talking about Evan, we're not talking about Gina, so 3 times last year's prize minus 20 divided by 2 would represent how much Evan's going to make. So it says this year's prize is 20 less than another amount. Will 20 be the first amount or the second amount? And we need to explain that. Okay, and so it definitely needs to be the second amount because whatever it was 3 times last year's amount, we want 20 less than that. So it definitely needs to be the second amount. 20 is subtracted from the rest, from the 3 times part. So the minus 20 definitely needs to be second, not first. It says, explain how to write an expression for 3 times last year's prize. Okay, so 3 times last year's prize. If we said that last year's prize, if we just said that that is represented by P, 3 times that would be 3P. You just squish those together. When you squish a number against a letter, that means multiplication. So that's how I would represent the expression for 3 times last year's prize before I even considered the less than part. Just for just this phrase, I would say 3P. They may use a different variable than P, but okay, X. So X is last year's prize. So if we're going to use X as last year's prize, then 3X would be 3 times last year's prize. And again, you can see that just squish the X with the 3 right next to each other, and that indicates multiplication. So let's write an expression for 20 less than 3 times last year's prize. So if we know that 20 less than means that that should be the second amount, and we know that 3 times last year's prize is represented by 3x, then we could represent the entire phrase as 3x minus 20. But we're still not done yet, because really what we're asking about is just only Evan's cut of the prize. He only gets half of the prize. And so Chandler writes the expression 1/2 times the quantity 3x minus 20 to represent Evan's winnings. Is she correct? Explain. Yes, she would be correct, because Evan had to split the prize money with Gina. And when I know that we need to figure out half of something, I need to know what 1/2 of 3x minus 20 is. I know that this word of, I need to know what 1/2 of it means multiply. And so I could write that or represent that by squishing it up against the parenthesis that indicates multiplication. And we can figure that out. Multiplying by 1/2 is the same as dividing by 2. Another way that you maybe could have written it would be 3 times last year's prize, 20 less than that, all over 2, just like that, but it would all have to be over 2. So this expression would actually be the same as this expression. This one I would say 1/2 of, or this one I would say the words divided by 2. This one I would say half of, but they really mean they represent the same amount. Okay. So it says to explain how you can find how much money Evan wins if last year's prize was $50. Ooh, tricky. Okay, so if we were going to use this problem, we would actually have to use substitution. We would have to take out the letter, replace it with the number 50, and then follow order of operations to solve each part. So in this case, I think we're going to go ahead and use the expression that Chandler was using, 1/2 times 3x minus 20, and I'll go ahead and work that out for you here at the bottom. So what I'm going to do is I'm going to write the problem exactly the way it looks first. All right, and what I'm going to do next, I'm going to replace the variable, because that's something that we don't know, with exactly what we do know. Now we're deciding that last year's prize was $50, and x represents the amount last year's prize was. So I'm going to replace the variable with empty parentheses, and I'm going to put the number 50 in where the letter used to be. Okay, so we have parentheses and then another set of parentheses, which is fine. Now, order of operations says we need to do grouping symbols first. So I'm going to look at all the parentheses. I'm going to do what's inside of them first. I'm looking at this group of parentheses, but inside those I notice there's more grouping of parentheses. So I'm going to actually look at this innermost group of parentheses. There are no operations inside. I don't see any addition, subtraction, multiplication, or division inside these two parentheses. So I know they're not really necessary anymore. Okay, and that's how I know I can go ahead and proceed without them. Now, I still have grouping symbols, which are these guys, and so I'm going to continue to follow order of operations inside those grouping symbols. I have two operations, multiplication and subtraction. In order of operations, multiplying and dividing comes before addition and subtraction, so I'm going to write down everything exactly the same way again, and I'm going to change this multiplication part into 150. Okay, 1/2 times 150 minus 20. Now I still have grouping symbols and there are still operations inside, so I'm going to continue to follow order of operations inside the grouping symbols. And the only operation left to do is 150 minus 20, 130. Now I don't have any operations left inside the grouping symbols, these guys, so the parentheses are no longer really necessary. What I really have is 1/2 times 130. I know that half of 130 is 65. Or if you want to think of them as fractions and multiply straight across, 130 over 2 would also equal 65. So I know that Evan's earnings would be $65. Oh, looks like they used the other one. They used the other expression, which is fine as well. You can see a couple things I want to point out here in the book's explanation is they use the expression that I had said that would be equivalent to this one, but you can see that they used parentheses when they substituted, and they showed every single step all the way through until they found that it was 65. Eventually they did find that 130 over 2 as well, just like we did, and so you can see that the expressions are equivalent because I did the one that looked like it was being represented by the distributed property. The book did the one that looked more like a fraction where it's divided by 2 instead of half of. But you can see that we came with the same result. So just keep in mind, please, and try to be cognizant of order of operations, because if you're not using order of operations, then you are going to not have the correct amount of prize money. Parentheses, exponents, multiply, divide, add, subtract. Finally, it says the price of 1 share of XYZ Inc.'s stock drops by 2 cents on Monday. On Tuesday, the price goes back up by 5 cents. Write an expression with 3 terms to show the change in the price of XYZ stock. So what I can do is I'm going to assign a variable to what we're not sure of, like the unknown amount. And in this case, that's the price of 1 share. So when we read this problem again, it says the price of 1 share. It says how much that it drops by, and it says how much that it goes up by, but it doesn't actually say how much the price of 1 share is. And so the unknown is almost always going to be represented by a variable or a letter. So because we don't know the price of 1 share, we're going to represent the price of 1 share as the letter S. So we're going to call him S. And if the stock is dropping by 2 cents, then really what I'm doing is I'm subtracting 2 cents from however much the price started at. And then if it goes back up by 5 cents, I'm going to be adding 5 cents later on. So overall, if I started with a price of a stock and I took away 2 cents and then I added 5 cents, then that would be an expression to represent how much money the stock is worth after Tuesday. It says that if 1 share of XYZ stock costs $34.18 at the start of business on Monday morning, what is the price of 1 share of XYZ stock at the close of business on Tuesday evening? So it looks to me like it's saying that instead of using the letter S, what we really have is this much money is how much it's worth right now. So instead of just S, I'm going to take out S. I'm going to put in $34.18 minus 2 cents plus 5 cents. So this is something that we could practice with our decimal addition and division, or our decimal addition and subtraction, lining up the decimal, making sure we have tenths with tenths, hundredths with hundredths, and all that stuff. But really, this is more of a mental math problem, if you think about it. So $34.18 minus 2 cents would be $34.16. And then 5 cents on top of that would be $34.21. So there was really just a net change of 3 cents in the positive direction for this problem. That's how I would have thought about it. If I think about a 2 cent decrease and a 5 cent increase, really we're increasing by 3 cents. So $34.18 plus 3 cents would really be $34.21. So that's how much that his stock would be worth at the end of Tuesday. Okay, so that's it for today. Hopefully those phrases are coming a little bit easier for you to work with. Careful on the ones that say more than and less than, those types of things. And when you're substituting, please be sure to make your replace your letter with parentheses before you put the number in. And that's it.